If you're at any reasonably sized company, a big part of your job will be to fix and maintain code rather than writing brand new code. And that means debugging is a critical skill for every software engineer. At the same time, so many of the engineers I've talked to from my time as a staff engineer at Meta and now running Taro have told me that they have a lot of anxiety when they get assigned a high priority bug. In this video, I'll cover the debugging tactics I've used dealing with thousands of bugs throughout my career. The last tip is my favorite. It's so easy to do, but so many people don't do it. The first thing I want to comment on is the mindset around debugging. You should be excited to fix difficult bugs. There's a tendency among engineers to gravitate toward feature work instead of bug fixing, and that kind of makes sense. There's a lot of glamour and attention on the new product or the new feature launch. But the reality is that as long as we have humans writing software, the software we write will have bugs. And that becomes more common and more complicated as you go into a bigger tech company like a FANG. And so the fact that most engineers neglect bugs is actually a huge opportunity for you. One of the lessons I've learned throughout my career is that a lot of your growth can come from simply caring more about a topic than other people. And so in the context of bugs, what that means is you have this desire and this drive to fix issues in the software more than anyone else on your team. And so whether that is a user report issue that you can immediately address and fix, or fixing small paper cuts in the product that have accumulated over time. If you do that for a long enough time period, that will be a huge amount of impact for your team and you'll gain a ton of respect for it. In fact, the most senior engineer I worked with at Meta, he was an L8 principal level engineer. The reason he got promoted to that level is because he was a fixer. You gave him any kind of issue on one day and the next morning he would have a proposed fix for it, whether that was a one-line change or if he had to dive into 3 different code bases and figure out how they all work together, and still he was able to produce a fix. And the last part about mindset here is that the deductive reasoning that you need in order to become a good debugger, that skill is applicable across all of software engineering, and in fact, across every single job that you have. It's a very transferable skill of trying to figure out how A leads to B and what could go wrong in that process. Now let's talk about debugging tactics. And this first one is unknown to pretty much every junior engineer, but it's incredibly powerful, which is to figure out the context around a bug. There's a tendency to jump right into the code when you're debugging an issue, and you start fooling around with that file related to the issue. But that's usually a mistake. I almost never do that. Instead, you should understand the context, which means when did the issue start? Is the bug 100% reproducible? And who is it impacting? Are there particular users or particular platforms or versions that are impacted by this issue? Simply gathering all this information is extremely valuable, but also quite complicated. At a large company like Meta or Amazon, you will literally have dozens or hundreds of changes that are happening in any given day. You might have an experiment getting rolled out, you might have a new version of the mobile app getting released, or you might have a holiday or some other change in user behavior which could cause anomalies. My recommendation is to document all of this and put it directly in the task for the bug or a new document that people can add to and share. Many of the issues that I fixed while I was on call at Meta actually had nothing to do with my understanding of the code. Instead, I would simply look at a correlation of a spike in a dashboard with the rollout of a certain commit. And then I would just experiment and back out that commit, revert that commit, and see if it solved the issue. So your goal is to understand how does software get released at your company, and then be familiar enough with the tooling that you can pull all that data together in one cohesive document. One general rule when you're dealing with a complicated system is that it's almost always better to fix an issue by backing out a change rather than fixing forward. For example, if you know a regression is coming from a range of commits, you can use git bisect to identify the offending commit and then test if reverting it will fix it. So at least you have one option of moving forward if that works. Now you know the context and timing around a bug. Now you can finally dive in and understand the code and the overall flow. Every software feature is a series of steps. It's an algorithm telling the computer what to do. And so your job is to understand what those steps are and what assumptions are being made along the way. Step 1 here is to reproduce the bug on your own, which is important because you don't want to make a blind fix and hope that it works. You want to have confidence in that. A lot of the larger companies will have a QA team, a quality assurance team, and they'll be really good about giving you all the necessary information on how you can repro the issue. And there were some really funny stories here at Meta where like the QA team would send a video of an issue where they would go 3 screens deep, back out once, rotate, go into the screen again, and then rotate again, and that would cause an issue. And so having that video or a very clear set of steps is extremely valuable for you to start diving into the code and understanding what's happening. Next, you should dive into the code. And there are 3 layers to this. And the first layer is the most new tool in my toolkit, which is to copy paste whatever relevant code in the ChatGPT and ask it for an explanation of what's happening. And that gives you like a baseline understanding that you can then build off of. Second is to add debug or print statements and then run the program and see how everything's getting called, what is the output of certain variables, and you can also step through it with the debugger. And the third layer is to talk to your team. Use debugging as an opportunity to build up an end-to-end understanding of the code base and also deepen the relationship with your team. How you should deal with your teammates, the QA team, with leadership team, all of that is actually very context dependent, depending on what level and what company you're at. And mentorship is all about giving you contextually relevant advice. And that's why I built Taro. On Taro, we have a really active forum with hundreds of big tech engineers who are talking about the inside perspective on career growth. And they give really valuable feedback tailored to your specific situation in a way that you wouldn't be able to capture with a generic video. So check it out at jointaro.com. I'll leave a link for it in the description. The next tip I have is to generate a paper trail. As you go through the debugging maze and you try different experiments, write down what you've done. When you try something and it doesn't work, and that'll certainly happen as you're debugging something, document that. Writing things down has 3 major benefits. Number 1, it prevents you from trying the same thing twice. A very common failure mode when you're frustrated with a bug is that you've tried 10 different experiments, but you forget the outcome of those in your 11th attempt. Number 2, if you need to transition off the bug because you're going on vacation or if you're ending your on-call, having a written down version of everything you've tried is super helpful for the handover. And the third benefit is that onboarding someone else to help you debug becomes way faster when you have a written record of everything you've tried. Your notes will help that new person immediately figure out where you are mentally. The next tip I have is to be deliberate about the 2 broad approaches to debugging, top down or bottom up. There's a really relevant quote here from Kent Beck, who is a very famous programmer, and he said, "When faced with a hard change, first make it easy. Warning, this may be hard, and then make the easy change." And this quote is extremely applicable to debugging. Top-down debugging means that we start with the whole code base, and then we remove parts of it, that's the hard part, in order to more easily debug the core issue. Typically, the way we do this is by commenting out parts of the code so that we can reduce the surface area. The top-down approach is good if the debug and iteration cycle on this massive code base isn't too long. And number 2, if there's a bunch of components that you're not sure how they interact, then it's better to start with everything working and then you kind of pare it down. The other approach is bottoms up, which is to start with a brand new project which you have high confidence is completely bug-free. Then you add things into that project until you can recreate the bug. This approach is good if the debug and iteration cycle on the production code base is very painful, and so you want to learn a lot faster by going into a vanilla project. Or number 2, if the number of components is relatively small or you have high confidence of where the issue is coming from, then going bottoms up will give you a much deeper end-to-end understanding of how that component works, and you can figure out the delta between what you're building out from scratch and what you have in the production environment. Over time, once you've done enough debugging, you'll build up some intuition about which of these approaches, top-down or bottom-up, is more suitable for your scenario. The last tip I have is my favorite, which is to take a break. And it's so easy to do, and yet when you're frustrated and stressed out with debugging something, it's really hard to pull yourself away from the computer. The issue is that when you're tunneling and you're deep into a bug, it's really easy to then start rabbit holing, where you're going down a path which you kind of know doesn't actually make sense, but it's really hard to pull yourself away from that. Going for a walk or taking a shower can be really valuable to clear your headspace, and then you come back to the computer with a renewed attention to detail and a new amount of creativity. Usually when I'm dealing with a really difficult bug, there is some amount of creativity that's required. For example, I might deliberately put in bad input to figure out how the program behaves. I might change the order of a certain function in order to figure out the output of that. And those all give me hints about what is actually happening. And so if you're really frustrated, you're losing sleep, you're stressed out, it's actually hard to be creative in that way. And so taking a break, taking a step back from your computer can be really valuable to allow yourself the clarity and the creativity that is so essential in debugging. Remember, software engineering is a team sport. You can and should loop in your team when you need help. A big part of working with your team is communication. So here's a video I made with 8 practical communication tips that will help you leverage your team more effectively. With these debugging tips in mind, getting a high priority bug won't be as daunting. Enjoy your newfound confidence and happiness. Thanks for watching, and I'll see you in the next one.